Welcome back to my channel. Today we talk a little bit more about the circle theorem. Let's look at the circle. Here, you can see different points here on the circumference, right? So these points are known as concyclic points. So what are concyclic points? The points which lie on the circumference of a circle are known as concyclic point. Look at here. You can see a quadrilateral inside a circle, right? So this quadrilateral is known as cyclic quadrilateral. Why it is called cyclic quadrilateral? Because every point of the quadrilateral lie on the circumference of a circle. Now, in a cyclic quad, what will happen? Let's see. The sum of opposite angles of cyclic quadrilateral is always 180 degree, which means that angle A plus angle C is equal to 180 degree, as well as angle B plus angle D is equal to 180 degree. Now look at this problem. Now we have to find here ABC, okay, the value of ABC. Before we finding, we are trying to use the cyclic quadrilateral properties here. As we know that in cyclic quadrilateral, opposite angles are, sum of opposite angles is 180 degree. But before we use that property, do you think that quad OABC is a cyclic quad? Not at all, because O is the center of the circle and O does not lie on the circumference of the circle. Obviously, OABC is not the cyclic quadrilateral. Now, in order to use the cyclic quadrilateral concept here, we have some technique here. Look at here. We can join here. We can join here A and D as well as C and D, right? What will happen when we join A and D and C and D? It will become ABCD becomes a cyclic quadrilateral, right? Now you can clearly see here ABCD is a cyclic quadrilateral. And in cyclic quadrilateral, what happens? The opposite sum of opposite angle is 180 degree, which means that angle B plus angle D is equal to sum of B plus D is equal to 180 degree, right? Now, in order to find the angle B, we need to first find the value of ADC. Look at closely here. ADC is the inscribed angle, which is standing on the arc ABC, right? And the same arc ABC, you can see central angle AOC is also standing here. So what can we say now? So we can just say here, angle ADC equals to half of angle AOC, right? Why? Central angle and scribe angle standing on the same arc. Now here, ADC equals to 1 by 2, half into 120 degree, okay? And here, ADC equals to 60 degree. Now we found the value of the ADC. Now we are going to find the value of the ABC. How can we find it? Let's look at here. ADC plus ABC equals to 180 degree. Why? Sum of opposite angles of cyclic quadrilateral, right? And here, the value for ADC is 60 degree and angle plus ABC equals to 180 degree, which means that ABC equals to 180 degree minus 60 degree. That gives angle ABC is equal to 120 degree. Now, look at the same problem once again. Here, it is the same problem and we're trying to find out some alternative process here, okay? And let's see, this time we are not using the cyclic quadrilateral property here. Instead, we are trying to use the central angle concept here. So look at, if you look here, you can see this is the center of the circle O, right? And here's 120 degrees, the central angle. And if you look at this angle, this is also central angle. But this angle is central. We call it reflex central angle. This AOC reflex AOC. Look at it, reflex AOC, this one. Okay, this reflex angle AOC standing on the arc, big arc. Look at here. This is a major arc AXC. Now, once again, I'm telling you, reflex angle AOC is standing on the big arc AXC, right? If you look into the angle ABC, look at here. This is the inscribed angle here. And this is also standing on the big arc AXC, right? So now we can make a relation of the reflex angle AOC and ABC, inscribed angle and the central angle relation. So that's why we can just say here, look at here, we can just say here, angle AOC plus reflex angle AOC equals to 360 degree. Why? Sum of angles in a complete rotation, right? Now just keep the value of the AOC as 120 degree plus reflex angle AOC equals to 360 degree. Now, reflex angle AOC equals to 360 degree minus 120 degree. That means reflex angle AOC is equal to now 240 degree, correct? Now we found reflex angle AOC, and remember, reflex angle AOC is standing on the arc AXC, which is the central angle. Now we can just make a relation here. Angle ABC, which is standing on the big arc AXC, right, is equal to half of reflex angle AOC. Why? Central angle and scribe angle standing on the same arc AXC, right? Now this gives that ABC equals to half into 240 degree, which gives that angle ABC equals to 120 degree. So we got the same value, just like this is the alternative process, right? Now, let's look at another problem here. Look closely at this problem. Here in this problem, we have to find the value of CED. Now, just remember here AC is parallel to ED. As soon as AC is parallel to ED, we can use the alternate angle concept. Can you see the angle in the Z form? ACE is equal to CED, correct? Okay, now we need to find out the ACE in order to find the value of the CED. Now, we just focus on the ACE, right? Now, in order to find this angle, now let's join this line, A and E. Let's closely look at this. We are just joining A and E. Now, when I join A and E, what happened? AEC becomes a triangle. Not only that, you can see AC is the diameter. AC passes to the center. Oh, that's why AC is the diameter here. And once it is a diameter, it divides the whole circle into two parts. Look at the lower part of the circle. It is a semicircle. And you can clearly see that AC is the angle which is formed at the semicircle. So we can say here, angle AEC is equal to 90 degree. Why? Angle in semicircle. Okay. Now, next, now we have found the AEC, right? If you look into the AC triangle, we found angle AC. Now concentrate the angle EAC. First of all, look at here. EAC standing on the arc EDC. Got it? EDC. Now on the same arc EDC, if you look closely, you can see angle B is standing on the same arc. So we can say here angle EAC is equal to angle B, because both the angles are standing on the same arc, and that arc is EDC. Look closely. Now we can give the region like this. Inscribe angles standing on the same arc EDC. Got it? Now here we can say that's why the value of the EAC is 60 degree, right? Correct? Now we found the value of EAC also. Now we are going to find out the value of AC. How can we find out? If you look into the triangle, we know that AC plus EAC plus AC equals to 180 degree. These are all the angles of the triangle. We can write here sum of angles in a triangle. Okay. Now look at the value of the AEC, that is 90 degree, plus EAC 60 degree, and plus angle AC is 180 degree. And here angle AC is equal to 180 degree minus 150 degree. 90 degree plus 60 degree gives you the 150 degree, which now AC is equal to 30 degree, right? So we found the value of the ACE. Now here we can say ACE is equal to CED. Why? It is the alternate angles. AC is parallel to ED. Now here we can say angle CD equals to 30 degree, because AC is 30 degree. Already we found it. Now here we can say CD is equal to X. So the value of the X is equal to 30 degree.